I already know your teachers been teaching you about mass spectrometry. This is day 2 of a minute of chem every day. Today is 1.2, mass spectroscopy/spectrometry. I know what you're thinking. What even is mass spectrometry? Well, it's not too hard. I'll cut all the fluff and teach only what you need. First, what's an isotope? Let's start by defining each of the numbers on the periodic table. The one on the bottom is your molar mass / AMU. So protons and neutrons that each weigh or have a mass of 1 AMU. And adding them up is your molar mass / AMU. Don't worry about the electrons. They have negligible mass. The number on the top right, that's your atomic number. That's how many protons you have, and that defines what element it is. For example, carbon has 6 protons. All carbons have 6 protons, and that's why it's carbon. But each element can have different amounts of neutrons, so they have different weights. So these different types of this elements are called isotopes. Okay, now what's mass spectrometry for real? Mass spectrometry is a technique where a sample of some element is blasted with energy and ionizes, and since isotopes have different masses, they reflect differently, and that's how we can measure how much of each isotope we have. Blah, blah. You don't need to know that. All you need to know is how to read the graphs. So it measures the relative abundance of an element on the y-axis. That's basically how much percent of that sample is a certain type of isotope. So how do we use this? So we can use this to find the mass of the whole molecule. And we do this by multiplying the AMU by the percentage measured by this graph, right? And that is a proportion. So 50% of isotope A, which let's just say is 35 AMU, we would multiply that by 0.5 because 0.5 is 50% as a proportion. Since mass spectrometry measures all 100% of the elements, or at least 99.9% of the elements, we would multiply all the isotopes by the proportions and add them up, and that's the mass. All right, let's go over a problem now. So there's actually 2 problems that you'll see. The second one is this graph. So it's the same concept, but you have to read the graph for this one. So it's still 182 times the proportion of relative abundance, right? That's a percentage. We need to put it as a proportion. So we have, this is about 25%, so 20.25 proportion. This one is 15. This one is about 30, and this one's also about 30. So what we're going to do is we're going to do the same thing. 182 times 0.25, because that's the proportion of this isotope. And then we have 183 times 0.15 plus 184 times 0.3 plus 186 times 0.3. Okay, and then we're going to calculate this, which is 183.75, but as you can see, that it's not a mass down here. So what we have to do is we have to go to the periodic table and look for this number, right, in the bottom number, because this is our AMU, or mass, and that's the same as this measurement right here. So we're going to look for 183 or 184, and that right there is tungsten. So our answer is B.